Are you familiar with these symbols or these symbols? Before we start our video tutorial, make sure to like and subscribe Kasiligan Vlogs official YouTube account to get more updated on exciting video tutorials. What does these symbols mean and how are we gonna use it? Good day everyone, this is Mathematics in the Modern World and I am about to present to you a video tutorial about mean, median, and mode of group data measures of central tendency. The mean, median, and mode are the three metrics that are commonly used to describe the center of a data set. The following examples explain how the mean, median, and mode are used in different real-life scenarios. Mean, median, and mode in healthcare, real estate, human resources, marketing, and any additional resources.
What is mean? Mean is the average of the given set of values and it has two formulas that we can use to compute the mean group data.
Mean for group data. To compute the mean for group data, we can use the two formulas, namely first, the class mark formula, and the second, the coded formula. How are we going to solve for the mean using class mark formula? Let's find out.
First, let us discuss on how to use the class mark formula. The sample mean formula is x bar is equal to summation of f of x over n, and the population mean formula is mu is equal to the summation of frequency times the class mark over n. And these are the meanings of the samples. First, mu is the population mean, x bar is the sample mean, x is the value of the observation, big letter N is the total number of values in the given population, small letter n is the total number of values in the given sample, and f is the frequency. These are the 5 steps to compute the class mark formula. First, construct FDT or the frequency distribution table. Second, find the midpoint of each class. Third, multiply the frequency by the midpoint of each class. Fourth, find the summation of f of x. And lastly, apply the formula in getting the mean.
And now, let's proceed to the example.
So here, we are given an example which is a class mark formula. Below is the frequency distribution of the scores of 40 students in mathematics in the modern world. So here, we're gonna find the answer of a class mark. So below we're given a class interval which is 9 to 14, 15 to 20, 21 to 26, 27 to 32, 33 to 38, 39 to 44, 45 to 50. Well, the frequency is 2, 4, 4, 6, 13, 8, and 3. So the value of n here is 40. To solve for x, we need to add 9 plus 14 divided by 2 to get the answer of 11.5. And now we need to add 15 plus 20 over 2 to get the answer 17.5. Next is 21 plus 26, divide it by 2 to get the answer of 23.5. Next is 27 plus 32, divide it by 2 to get the answer of 29.5. And now, we need to add 33 plus 38, divide it by 2 to get the answer of 35.5. Next is 39 plus 44, divide it by 2 to get the answer of 41.5. And lastly, we need to add 45 plus 50, divide it by 2. The answer will be 47.5. So this is the answer of our x. And now let's solve the f and x, which is we need to multiply the answer of x and the frequency. So, 2 times 11.5, the answer will be 23. Next is 4 times 17.5, the answer will be 70. 70. Next is 4 times 23.5, the answer will be 94. 94. Next is 29.5 times 6. The answer will be 177. Then 35.5 times 13. The answer will be 461.5. 461.5. Next, 41.5 times 8. The answer will be 332. And lastly, we need to multiply 47.5 times 3. The answer will be 142.5. And now, the summation of fx is equals to 1,300. And now, let's solve for the class mark formula, which is we need to substitute all the values that are given. To solve for the class mark formula, we need to find the summation of fx, which is already given, and the n also. And now we need to substitute it by the class formula. So the summation of fx is equals to 1,300 over the n, which is 40, and to solve for the class mark formula, we need to find first the summation of fx over the n, which is already given and already solved. And now, let's proceed and distribute the values that are given.
How about finding the mean using coded formula? Let's take a look at this short clip.
For the coded formula, we have x bar equals xam plus the summation of fd over n times I. Where x bar stands for the mean, xam for the assumed mean, f for the frequency, d for the coded deviation, n for the total frequency, and I for the class size. For the steps, step 1. Choose any class interval to find the assumed mean. The class mark of this interval is xam. Step 2. Construct the column for the deviation. This is done by putting 0 as a deviation for the assumed mean, deviation from itself. For the class interval larger than the class interval which contains the assumed mean, the deviations are 1, 2, 3, and so on. And for the class interval smaller than the class intervals which contains the assumed mean, the deviations are negative 1, negative 2, negative 3, and so on in that order. Step 3. Multiply each frequency by the corresponding deviation to get the entries in the FD column. Step 4. Get the sum of the values obtained in step 3 to obtain the summation of FD. Step 5. Use the formula to compute the mean.
Here's an example of a table, and let's try to solve it using the coded formula. In coded formula, let's first pick this one as our class interval to find the assumed mean. The class mark of this interval is this one. Class mark x is 27 plus 32 divided by 2, so we have 29.5. Next is construct the column for deviation. This is done by putting 0 as a deviation of the assumed mean. For the class intervals larger than the class interval which contains the assumed mean, the deviations are negative 1, negative 2, negative 3, and so on in that order. Multiply each frequency by the corresponding deviation to get the entries in the FD column. 2 times negative 3 is negative 6. 4 times negative 2 is negative 8. 4 times negative 1 is negative 4. 6 times 0 is 0. 13 times 1 is 13. 8 times 2 is 16. 3 times 3 is 9. Next, Get the sum of the values obtained in step 3 to obtain a summation of FD. Negative 6 plus negative 8 plus negative 4 plus 0 plus 13 plus 16 plus 9 equals 20. Then use the formula to compute the mean. Mean equals assumed mean plus summation of FD over the n times the interval. Assumed mean, which is 29.5, plus summation of FD, which is 20 over n, 40 times the interval, which is 6. Therefore, the mean is 32.5, which is the same when we solve the problem using the class mark formula. Median is the middle value of the distribution when the values are arranged in ascending or descending order. We can use our formula in finding the median. Here's how.
This is the formula in finding the median in a group of data. Mean equals median equals lower boundary of the middle class plus open parentheses total frequency over 2 minus less than cumulative frequency above the median class over frequency of the median class close parentheses class intervals.
Steps in solving the median. First step is you must construct GFDT or the group frequency distribution table. Second step is to determine the median class. Median rank value equals n over 2. The next step is to construct a cumulative frequency column. Then identify the median class. The next step is to determine the lower boundaries, cumulative frequency, interval, and the total number of values in a given population. The last step is to apply the formula to compute the mean.
And now, let's proceed to the example of median. Below is the frequency distribution of the scores of 40 students in mathematics in the modern world. So now we're given the following data here. So, we're gonna find the less than cumulative frequency above the median. In finding the less than cumulative frequency is to add it by the frequency. So here, since we have no value of less than cumulative frequency, let's imagine there is a 0 here above. So 0 plus 2, the answer will be 2. And then we need to add 2 to the frequency to get the answer of 6. Next is we need to add the value of 6 to 4 to get the answer of 10. Next is we need to add 10 to 6 to get the answer of 16. And then we need to add 16 to the frequency, which is 13. The answer will be 29. And then we need to add 29 to 8 to get the value of 37. And lastly, we need to add 37 plus 3 to get the value of 40. So the formula we'll be using is MD is equals to LB, which means lower boundary plus n over 2 minus the less than cumulative frequency all over the value of frequency multiplied by the interval. In finding the interval, we need to locate here in the class interval what is the lowest value and the highest value. So, the formula is I is equals to HV plus LV, which means the highest value and the lowest value all over the number of class marks. mark. Okay. So, the highest value here is 50, while the lowest is 9. And the class mark here is 7. So that the answer will be 5.85 or 6 or 6. We will find the answer of this, n over 2. So, the value of n is 40. All over 2, the answer will be 20. And now, we will be applying the formula of median, which is MD is equals to LB, which means the lowest boundary plus n over 2 minus the less than cumulative frequency all over the frequency times the interval. The LV here is 32.5. Why is 32? So, here is the answer. To get the value of 32, since we all know that the value of n over 2 is 20. So, the nearest value of 20 is 29. So here, 29, and the class interval here is 33. So, we need to minus 33 by 0.5 to get the answer of 32.5. And now we're gonna substitute the value of n over 2, which is 20 minus the less than cumulative frequency, which is here 16. So we're gonna put here 16 all over. So the frequency of 29 is 13. Here, as you can see here, 13. So we're gonna put here 13 and multiplied by the interval, which is 6. So let's answer this. So the answer here is 34.35.
And now, let's have the computation of mode for group data in unimodal distribution.
Mode for grouped data unimodal distribution. So here's a formula on how to get mode for group data. Mode equals lower class boundary of the model class plus quantity of frequency of the model class minus frequency above the model class over 2 frequency of the model class minus frequency above the model class minus frequency below the model class times size of the class interval. And there are only 2 important steps in getting the mode for group data. First, find the model class. This is the model interval with the highest frequency. And lastly, use the formula to find the mode.
How about mode for group data in multimodal distribution? Watch this.
The formula for multimodal distribution to get the mode for group data. The formula for this is MO is equal to 3MD minus 2X bar, where MO is the mode, MD is the median, and X bar is the mean. So the first step is to construct a group frequency distribution data. Next step is to determine the model class. Note that the model class for the group data is the class with the highest frequency. Third step is to determine the median and the mean. And the last step you need to do is to apply the formula to compute the mode.
This is the frequency distribution of the scores of 40 students in mathematics in the modern world. Let's find the mode of the group data. First, we have to locate the model class. This is the model class because this is the class interval with the highest frequency. Next, we have to use the formula to find the mode. So our LM is the lower boundaries, which is 32.5, FM, which is 13, frequency above the model class, which is 6, frequency below the model class, 8, and the interval, which is 6. After that, we have to substitute the given values to the formula. 32.5 plus 13 minus 6 over 2 times 13 minus 6 minus 8 times the interval, which is 6. By computing the mode using the formula, we can have 36 as the mode of the frequency distribution of the scores of the students. That's it for our video tutorial. Hope you all guys learn and discover something interesting. Thank you.